Hello students, last lecture I have taught you distance formula. Next point from this chapter is section formula. Suppose here are 2 points A and B with coordinates x1, y1 and x2, y2. This is a line segment joining these 2 points A and B, and point P is in between these 2 points. Its coordinates are x and y. This point P divides this line segment in the ratio m is to n. Then the coordinates of point P are given by the formula x equals to mx2 plus nx1 upon m plus n, y equals to my2 plus ny1 upon m plus n. This is called as a section formula. If point P is midpoint of AB, then x equals to x1 plus x2 upon 2 and y equals to y1 plus y2 upon 2. This is called as a midpoint formula. Here is the first example. If A35 and B79, point Q divides seg AB in the ratio 2:3, then find coordinates of point Q. Suppose AX1 Y1 35, BX2 Y2 79. These are the given points. Let QXY divides AB in the ratio 2:3. That means value of M is 2 and that of N is 3. Bisection formula: x equals to mx2 plus nx1 upon m plus n. M is 2, 2 into x2 is 7, 2 into 7 plus n is 3 and x1 is 3, 3 into 3 upon 2 plus 3, 2 7s are 14 plus 3 3s are 9 upon 5, 14 plus 9 is 23, 23 upon 5. This is value of x. Y equals to my2 plus ny1 upon m plus n. 2 into 9 plus 3 into 5 upon 2 plus 3, 18 plus 15 upon 5. 18 plus 15 is 33 upon 5. So coordinates of point P are 23 by 5 and 33 by 5. If point T divides the segment AB with A minus 7 4 and B minus 6 minus 5 in the ratio 7:2, find the coordinates of T. Suppose AX1 Y1 minus 7 4 and BX2 Y2 minus 6 minus 5. Let point TXY divides AB in the ratio 7:2. So here value of M is 7 and that of N is 2. Bisection formula: x equals to mx2 plus nx1 upon m plus n. 7 into minus 6 plus 2 into minus 7 upon 7 plus 2. 7 into minus 6 minus 42. 2 into minus 7 minus 14 upon 9. Minus 42 minus 14 is minus 56 upon 9. This is value of x. Y equals to my2 plus ny1 upon m plus n. 7 into minus 5 plus 2 into 4 upon 7 plus 2. 7 into minus 5 is minus 35 plus 8 upon 9. Minus 35 plus 8 is minus 27 upon 9. 9 3s are 27. Value of y is minus 3. Coordinates of point T are minus 56 upon 9 and minus 3. Third example here, point P is midpoint of seg AB with A minus 4 2 and B 6 2. Find coordinates of point P. These are the given points. Suppose AX1 Y1 minus 4 2, BX2 Y2 6 2. Let PXY is midpoint of seg AB. Therefore, by midpoint formula, x equals to x1 plus x2 upon 2 minus 4 plus 6 upon 2. Minus 4 plus 6 is 2, 2 upon 2. Value of x is 1. Y equals to y1 plus y2 upon 2. 2 plus 2 upon 2, 4 upon 2 is 2. Therefore, coordinates of point P, which is midpoint of seg AB, and these coordinates are 1 and 2. Next point from this chapter is centroid formula. We have learned the properties of triangles in 7th and 8th standard. Here is triangle ABC. This line segment AD is called as a median of the triangle. A line segment joining vertex of a triangle to the midpoint of side opposite to it is called as a median. A triangle has three medians emerging from three vertices, and all the three medians cut each other at a single point, and this point is called as a centroid, denoted by G. So here by centroid formula you have to find out coordinates of G. Gxy is centroid, therefore by centroid formula x equals to x1 plus x2 plus x3 upon 3, y equals to y1 plus y2 plus y3 upon 3. Next example related to the centroid formula. Points minus 7, 6, 2, minus 2 and 8, 5 are vertices of a triangle. Find coordinates of centroid. Suppose a x1 y1 minus 7 6, b x2 y2 2 minus 2, c x3 y3 8 5. So these are the vertices of triangle ABC. Suppose let gxy is centroid. So by centroid formula x equals to x1 plus x2 plus x3 upon 3, minus 7 plus 2 plus 8 upon 3, minus 7 plus 2 is minus 3 minus 5 plus 8 is 3 upon 3, value of x is 1. Y equals to y1 plus y2 plus y3 upon 3, 6 minus 2 plus 5 upon 3, 6 minus 2 4 plus 5 9 upon 3 is 3. So coordinates of centroid G are 1 and 3. Next problem related to this section formula is A 15 5, B 9 20. These are 2 points and A between P between B. Find the ratio in which point P 11 15 divides segment AB. Means here in this example you have to find out values of M and N. Suppose A x1 y1 15 5, B x2 y2 9 20. These are given points. P 11 15. So these are values of x and y. P 11 15 divides AB in the ratio M is to N. Therefore by section formula x equals to mx2 plus nx1 upon m plus n. (11) equals to 9m plus 15 upon m plus n. This m plus n which is divided gets multiplied. 11 in bracket m plus n equals to 9m plus 15n. Multiply by 11 to each and every term inside the bracket. 11m plus 11n equals to 9m plus 15n. 11m minus 9m equals to 15n minus 11n. 11 minus 9 2m plus 15n minus 11 4n. M upon n equals to 4 upon 2. So m upon n equals to 2 upon 1, and the required ratio is 2:1. That means point divides the line segment in the ratio 2:1. And the last point here, find the coordinates of the points of trisection of segment joining the points a2 minus 2 and b minus 7 4. So here are 2 points a2 minus 2 and b minus 7 4. This is the line segment AB joining these 2 points. We have to find out points of trisection. Trisection means here we need 2 points which divides this line segment in 3 equal parts. So here AP, PQ and QB are the 3 parts. Here coordinates of point P are assumed as x3 y3 and that of Q are x4 y4. Suppose A x1 y1 2 minus 2 and B x2 y2 minus 7 4. These are the 2 given points. Let P x3 y3 and Q x4 y4 be the points of trisection of seg AB. Therefore AP equals to PQ equals to QB. These 2 points make 3 sections or 3 equal sections of this line segment AB. So if you observe here, this point P divides this line segment AB in the ratio 1:2. All the 3 are equal. AP equals to PQ equals to QB. So AP and PB, this ratio is 1:2. Point P divides AB in the ratio 1:2. Therefore M equals to 1, N equals to 2. Bisection formula x3 equals to mx2 plus nx1 upon m plus n. 1 into minus 7 plus 2 into 2 upon 1 plus 2. 1 into minus 7 plus 2, 2s are 4 upon 3. Minus 7 plus 4 is minus 3 upon 3. Value of x3 as minus 1. Y equals to my2 plus ny1 upon m plus n. 1 into 4 plus 2 into minus 2 upon 1 plus 2. 4 ones are 4. 2 into minus 2 is minus 4 upon 3. 4 minus 4, 0. 0 upon 3 is 0. So coordinates of point P are minus 1, 0. Now we have to find out coordinates of point Q. We can find it out by two ways. Let me explain this one. If you see here, point Q divides this line segment AB in the ratio 2:1. These are the two parts here and this is one part. Or second way is, now we have got here the coordinates of point P, and if you observe here PQ equals to QB, that means Q is midpoint of PB. So you can find out by any ways, either by using sectional formula or this midpoint formula. So point Q is midpoint of PB, therefore by midpoint formula x4 is x3 plus x2 upon 2 minus 1 minus 7 upon 2 minus 8 upon 2 minus 4. Value of x4 is minus 4. y4 equals to y3 plus y2 upon 2, 0 plus 4 upon 2. 4 upon 2 equals to 2. So coordinates of point Q are minus 4 and 2. Therefore coordinates of points of trisection are minus 1, 0 and minus 4,